Today, we talk about the Manhattan Project. In the throes of World War II, the United States initiated one of the most secretive and monumental projects in history, the Manhattan Project. This clandestine endeavor was born out of a dire need to end a war that had consumed the world. As the conflict raged on, the United States realized that the only way to bring about a swift conclusion was to develop a weapon so devastating that it would shock the world into peace. The Manhattan Project was a research and development project during World War II, primarily focused on creating the first atomic bombs, a weapon of unprecedented power. Led by the United States with the support of the United Kingdom and Canada, it employed thousands of scientists, engineers, and workers. The project culminated in the successful testing of the first atomic bomb on July 16, 1945, in New Mexico. The subsequent bombings of Hiroshima and Nagasaki by the United States on August 6 and 9, 1945, respectively, brought about the end of World War II. The Manhattan Project's importance lies in its pivotal role in changing the course of the war, leading to Japan's surrender and the beginning of the nuclear age. The Manhattan Project was spearheaded by some of the brightest minds of the time, including physicists such as J. Robert Oppenheimer, often referred to as the father of the atomic bomb, who played a crucial role in leading the scientific efforts. Other key figures included Enrico Fermi, who achieved the first controlled nuclear chain reaction, and General Leslie Groves, who oversaw the project's logistical and administrative aspects. Scientists like Niels Bohr, Richard Feynman, and Edward Teller also made significant contributions to the project's success. Together, these individuals brought their expertise and innovation to bear on the immense challenges of harnessing atomic energy for military purposes, forever altering the course of history. Secrecy of the project was paramount. The project was so hush-hush that even Vice President Harry Truman was kept in the dark until he took the oath of office. Workers were sworn to silence, with many not even knowing the full scope of what they were working on. Have you seen the movie Oppenheimer? Tell us your thoughts if you have. The Manhattan Project wasn't just about building a bomb, it was about unlocking the secrets of the atom. At the heart of the atomic bomb lies the concept of nuclear fission. This phenomenon, discovered in the late 1930s, involves splitting an atomic nucleus into two lighter nuclei. The process releases a tremendous amount of energy. Picture the energy of the sun harnessed and unleashed in a single cataclysmic moment. But how does this process happen? It all starts with a neutron. When a neutron strikes the nucleus of a uranium-235 atom, it splits the nucleus, releasing energy and more neutrons. These newly liberated neutrons then go on to split more uranium nuclei, causing a chain reaction. This self-sustaining process is precisely what fuels the destructive power of an atomic bomb. However, harnessing this power was no easy task. The scientists of the Manhattan Project had to overcome numerous hurdles. One of the major challenges was obtaining sufficient quantities of uranium-235. This isotope of uranium is rare, making up less than 1% of all natural uranium. The process of separating it from the more common uranium-238 isotope was laborious and time-consuming. Then there was the problem of achieving a critical mass, the minimum amount of uranium-235 needed to sustain a chain reaction. Too little, and the chain reaction would fizzle out. Too much, and it could lead to a premature explosion. Despite these challenges, the scientists persevered. They were driven not only by the urgency of the war situation, but also by the thrill of scientific discovery. They were venturing into uncharted territories, pushing the boundaries of human knowledge. In their quest to end the war, these scientists were rewriting the rules of physics. They were unlocking the secrets of the atom, opening up a new realm of possibilities, and yes, creating a weapon of unprecedented destructive power. But they were also laying the groundwork for peaceful applications of nuclear energy, a testament to the dual nature of scientific advancement. In their quest to end the war, these scientists were rewriting the rules of physics. Don't forget to like and subscribe. Building the world's first atomic bomb was no small feat. Imagine the sheer scale of the task, like assembling a million-piece puzzle, but with each piece being a scientific mystery yet to be solved. The Manhattan Project, the code name for this monumental endeavor, was spread across multiple facilities in the United States, the most notable ones being Los Alamos in New Mexico, Oak Ridge in Tennessee, and Hanford in Washington. Each facility had a critical role. like different cogs in a giant machine, all working together for a single daunting task. The materials required were equally as extraordinary. Enriched uranium and plutonium were the key ingredients. These radioactive elements were unlike anything the world had seen before. Obtaining them was a Herculean task in itself. The uranium had to be mined and then painstakingly refined, while the plutonium was produced in nuclear reactors. And then there was the manpower. Thousands of the brightest minds of their generation, from physicists to engineers, were gathered from all corners of the globe. They worked day and night, fueled by a sense of urgency and the weight of the task at hand. But the journey was far from smooth. There were numerous challenges and setbacks. The process of uranium enrichment proved to be far more complicated than initially thought. The design of the bomb was fraught with difficulties. There were even fears that the bomb could ignite the atmosphere and destroy all life on Earth. Yet, they pressed on. Each setback only fueled their determination. They experimented, they innovated, they pushed the boundaries of what was known and unknown. They were driven by the belief that their work could end a war and save countless lives. The construction of the atomic bomb was a testament to human ingenuity and perseverance. It was a demonstration of what can be achieved when the sharpest minds are given a task of monumental importance and the resources to achieve it. Despite the enormous challenges, the scientists and engineers of the Manhattan Project remained undeterred. On July 16, 1945, the world's first atomic bomb was detonated in the New Mexico desert. The day dawned with an air of anticipation, a taut string of suspense. This was the day of the Trinity test, the first ever detonation of an atomic bomb. The preparations leading up to this moment were shrouded in secrecy. A team of scientists under the banner of the Manhattan Project had spent countless hours and expended vast resources to bring this moment to fruition. All their efforts were concentrated on a single solitary point in the New Mexico desert, a point that was soon to be the epicenter of a new age, the atomic age. Sweaty palms adjusted instruments, eyes squinted through protective goggles, and hearts pounded in chests as the countdown began. The tension was palpable, the anxiety a living entity. This was uncharted territory, a step into the unknown. The question on everyone's mind was simple yet profound. Will it work? And then, in an instant, the desert was bathed in an intense, blinding light. A colossal mushroom cloud surged towards the heavens, a testament to the destructive power now in human hands. The shockwave rumbled through the ground, the heat seared the earth, and a new chapter in human history was written. The aftermath of the Trinity test was a mixed bag of emotions. There was relief that the bomb had worked, joy at the scientific achievement, and a sense of awe at the sheer magnitude of the power unleashed. But there was also a sense of trepidation, a realization of the potential consequences of this new weapon. In the words of J. Robert Oppenheimer, the scientific director of the Manhattan Project, "Now I am become death, the destroyer of worlds." These words, borrowed from the Hindu scripture Bhagavad Gita, encapsulate the duality of the atomic bomb, a marvel of science, yet a harbinger of destruction. With the successful test of the atomic bomb, the Manhattan Project had achieved its objective. The atomic age had dawned, and the world would never be the same. In August 1945, the atomic bombs were dropped on the Japanese cities of Hiroshima and Nagasaki, an event that forever etched itself into the annals of history. As the final stages of World War II played out, the United States made a decision that would not only end the war but change the world. The Manhattan Project, a covert operation that had been in motion for years, was about to reach its climax. The stage was set for the first and, to date, only use of nuclear weapons in war. On August 6, 1945, a B-29 bomber named the Enola Gay took off from Tinian Island in the Pacific, carrying a uranium atomic bomb known as Little Boy. Hiroshima, a city of considerable military importance, was the target. The bomb exploded approximately 600 meters above the city, unleashing a force equivalent to 15,000 tons of TNT. The city was decimated. An estimated 80,000 people perished instantly. 3 days later, on August 9th, another B-29 Bockscar took to the skies. This time the destination was Nagasaki, and the weapon was Fat Man, a plutonium bomb. The explosion obliterated the city, killing an estimated 40,000 people instantly. The immediate aftermath was nothing short of apocalyptic. The cities were leveled, reduced to ashes and rubble. The survivors, the Hibakusha, were left to deal with the horrific burns, injuries, and the invisible, insidious threat of radiation sickness. The death toll would continue to rise in the months and years that followed, reaching into the hundreds of thousands. Yet amidst this devastation, a new world order was taking shape. Power dynamics shifted. The nuclear age had dawned, and with it, the terrifying potential for destruction on an unimaginable scale. The bombings of Hiroshima and Nagasaki were not just the end of a war. They were a stark demonstration of the power humanity now wielded, and a somber warning of the potential consequences of its use. The bombings of Hiroshima and Nagasaki marked the end of World War II, but they also marked the beginning of a new era of warfare. The Manhattan Project forever altered the course of human history. This statement may seem bold, but its weight becomes apparent when we delve into the aftermath of Hiroshima and Nagasaki. The human cost of the bombings was immense. In the immediate aftermath, over 100,000 lives were lost in the blink of an eye. Over time, the death count rose even higher, with countless survivors succumbing to radiation sickness, burns, and other injuries. The environmental impact was equally devastating, with ecosystems disrupted and areas rendered uninhabitable due to radiation. But amidst the destruction, the bombings marked the end of World War II. Japan's surrender on August 15, 1945, brought the most devastating conflict in human history to a close. The world breathed a collective sigh of relief, but the shadow of the atomic bomb loomed large. The legacy of the Manhattan Project is far-reaching. It heralded the start of the nuclear age, ushering in a new era of scientific discovery but also unparalleled danger. The balance of global power shifted as nations raced to develop their own nuclear arsenals, leading to the Cold War's tense standoffs. The ethical debates surrounding nuclear weapons are equally significant. On one hand, proponents argue that nuclear deterrence has played a key role in maintaining global peace. On the other, critics highlight the immense human and environmental costs, calling for nuclear disarmament. These debates continue to shape international relations and policy today. Even as we marvel at the scientific ingenuity that birthed the atomic bomb, we must grapple with the moral implications of its use. The Manhattan Project serves as a potent reminder of the duality of scientific discovery, embodying both the potential for human advancement and the capacity for destruction. In closing, we're left with this. The Manhattan Project, a testament to human ingenuity and determination, stands as a stark reminder of the power and responsibility that comes with scientific discovery. The lessons learned from this pivotal moment in history continue to resonate, urging us to wield our knowledge with wisdom and caution. The Manhattan Project, a monumental effort of science, engineering, and secrecy, forever changed the world. It began as a spark of an idea, fueled by the possibility of harnessing the power within an atom. A mammoth task that required the brightest minds of a generation to decipher the complex science behind it and put it into practice. The construction of the bomb, an epic feat of engineering, led to the test that would ignite a new era. The bombings of Hiroshima and Nagasaki, cities etched in our collective memory, marked the culmination of this project and the beginning of a new atomic age. The aftermath of the Manhattan Project was as profound as its inception, leaving an indelible mark on human history and legacy. In the face of immense challenges, the Manhattan Project stands as a testament to human ingenuity, a stark reminder of the power and responsibility that comes with scientific discovery.